Hey guys, it's Miss Miklos. Merry Christmas and Happy New Year's, and welcome back to this second semester of pre-calculus. And today we're going to start talking about Chapter 6, and it deals with what we call oblique triangles, which basically means all of the non-right triangles. Last semester we worked a lot with triangles, but everything we did was a right triangle, so we could use SOHCAHTOA, and just use our calculator and our special angles and all that fun trig stuff. Today, we're not going to be able to do that. So there's a few things that we're going to be learning in this chapter that's going to enable us to solve for an angle or a side of any triangle. The first of these, you guys have actually learned before. It's called the law of sines. And it is A over sine of angle A equals B over sine of angle B. And you guys learned this last year in Algebra 2. And sometimes we'll see this written a little bit differently with the trig ratios in the numerator and the sides in the denominator, but it really doesn't matter as long as we're consistent in how we write it. The thing that is important for us, we're used to writing our angles lately as Greek letters, and today we're going to be using capital letters. So we're going to use A, B, and C, and we know opposite from the angle, we write the side by using the lowercase version of that letter. So opposite from angle A is side A, opposite from angle B is side B, and you've guessed it, opposite from angle C is side C. And really what makes this different, we're used to angle C always being the biggest, which means side C is the biggest. And in this case, that's not always true because it's not a right triangle. So this is definitely a formula that you guys need to have memorized. And in our problems today, it's going to ask us to round all the answers to the nearest tenth, and it's going to give us information about the triangle. So, for example, number one, it gives us angle C, and side B. So I'm going to start by just kind of thinking about the information we have. And I notice that I have one side that's matching with an angle. And we're trying to find angle B, and they actually give us what side B is. And what we will eventually learn is normally when we're talking about two angles, we use the law of sines. When we talk about one angle, we use the law of cosines, which is what we're going to learn in our next lecture. So if I'm setting this up, I'm going to go ahead and say 52.7 over the sine of 80.3 degrees equals 41.6 over the sine of angle B, because that is our unknown value. And first of all, using common sense, I'm thinking angle B is going to be smaller than angle A is, than angle C is, because this side length of C is bigger than the side length of B. We need to go ahead and isolate sine of angle B, so we're going to start by cross multiplying. So I have 52.7 times the sine of angle B equals 41.6 times the sine of 80.3. Notice that we are in degrees, so you guys will want to make sure that your calculator is in degree mode. And we've talked about that a lot, but it's always important that we double check what mode are we actually in. So change your calculator right now. Okay. So now I'm going to go ahead and divide both sides by 52.7. And I notice that that isolates sine of angle B. That's still not telling me anything. We know that in order to find an angle, we are going to have to use sine inverse. So I'm going to do sine inverse, and we can do one of two things. We can input this entire expression into our calculator and do second answer. Or we can go ahead and just do sine inverse, and this is what I normally do. I normally just type in that entire expression, making sure to close parentheses, divided by 52.7. And when I go ahead and put that in, I get that angle B is 51.1 degrees. As I'm going through this, I know it's easy to think like, oh, we know how to do this, blah, blah, blah. However, I would just kind of go along and do the calculations with me to make sure that you actually know how to use your calculator. Moving on to number 2, I noticed that they talk about side B and angle B. However, we have a problem. It talks about side C, but we want to find side A. So what we're going to have to do is we're going to have to use the given information. So I'm going to say, not S, I don't know what I'm writing there. We're going to go ahead and say 71 over the sine of 110 equals 63 over the sine of angle C. And I know that C is not what we want to find. Okay, we actually want to find side A, but I think if we find angle C, we know that if we have 2 angles, we know what the third angle is because of our triangle sum theorem. So I can figure out what angle A is and in turn use law of sines again to find side A. So we're going to cross multiply and divide, and I'm doing that in a single step here. If you guys want to write it all out, totally fine. Okay, and I end up getting sine of angle C is 63 times the sine of 110 divided by 71. And when I put that into my calculator by doing sine inverse, I get angle C is 56.5 degrees. Now, once again, I said that doesn't matter, but what does matter is angle A because that can help us find side A. So I'm going to go ahead and add the 2 angles we know together and subtract it from 180, and I end up getting 13.5 degrees. So right away, I'm noticing that side A is definitely going to be the smallest one because angle A is the smallest angle. So now we're going to set this up again, and I'm going to use the information that we don't know. So A over the sine of 13.5 degrees, and then I'm going to use the given information. And just so you guys know, when we are solving some of these problems, you can get slightly different answers that are still correct. And the reason why that happens is because of rounding, okay? We know that 56.5 was not an exact answer for angle C, okay? It was an approximated value, which is okay, but sometimes it affects our answer slightly. So when possible, I want to go ahead and use the given information. And while we're at that, some of you guys may be wondering, why didn't I just use the Pythagorean theorem? Why am I trying to make our lives more difficult? And the reason is we can't use Pythagorean theorem here because it's not a right triangle. And I think it's so ingrained in us to use that sometimes that's difficult to deal with. Okay, so let me finish this. I'm going to say 71 over the sine of 110. When I cross multiply and divide, I get 71 times the sine of 13.5 degrees divided by the sine of 110. Okay, so I did 2 things at once. I cross multiplied and then I divided by sine of 110 because I wanted A to be by itself. Here, I don't need to find an angle this time, so I'm just going to put this into my calculator. Just a reminder that whenever we're putting sine of an angle in our calculator, we need to close the parentheses. And I end up getting that A is 17.6. We don't have a label here given to us, so we're just going to leave it as 17.6. Number 3 gives us a triangle, and it gives us 2 of the angles and 1 side and asks us to solve for the triangle. And that means that we need to figure out every single part of the triangle. And this, let me get there, this might be really strange looking to us. And in fact, this represents 20 minutes. And basically what we need to remember is that there are 60 minutes in 1 degree. So if we wanted to actually approximate what this would be, I'm going to go ahead and do 49 and 20 divided by 60, because that's going to give us what fraction of a degree we actually have here. And I end up getting 49.3 degrees. Okay, I'm rounding to the nearest tenth because that's what it told us to do. If we left it at something else, it would definitely affect our answer. So the first thing I'm going to find here is I'm going to find the easiest thing, and that's angle C. I know I can find angle C using the triangle sum theorem. So I'm going to go ahead and do 180 minus the sum of those other two angles, and I get angle C is 69.7 degrees. And now we're going to have to use law of sines, and it really doesn't matter which one we use first, or which side we find first, if we find side A or side B. But in this case, I know that 5,396 over sine of 69.7 is going to have to be in our ratio. Okay, I am all over the place here. There we go. Okay, and that's because that's the only matching piece of information we have. We were given we were given side C, and we solved for angle C. So I'm going to go in order here. I'm an orderly person, and find side A. So I'm going to say A over sine of 61 degrees. When I go through solving that, and hopefully we feel pretty confident in that process at this point, I get that side A is 5,032.0. When I set up law of sines once again to find side B, when I cross multiply and divide and put that into my calculator, I get B is 4,361.8. Now, if we look at those three side lengths, they do make sense because we know that the biggest angle is actually opposite the biggest side here. Number 4 gives us angle A, angle B, and side C. Since side C is given to me, I'm thinking that angle C is going to be pretty important. So that's actually the first thing that we're going to find. Even though it says to find A, we need to find side C first. And in order to do that, I'm going to have to convert 10 minutes into degrees, and I get 102.2 degrees. So angle C ends up being, when we use triangle sum theorem, 54.8 degrees. So now I'm going to go ahead and use law of sines. So I'm going to say 576.1 over the sine of 54.8 degrees equals A over the sine of 102.2 degrees. So once again, I'm going to cross multiply and divide, and I get that side A is 689.1. Honestly, using law of sines does not get much more difficult than this. So as long as you guys know what sides and what angles to substitute in, if you know how to deal with ratios, we are in good shape. Now, looking at our next few problems, it's asking us to find something completely different. It's asking us to find the area. Okay, we know that the area of a triangle is 1/2 base times height, but the issue is when we have an oblique triangle, it's kind of hard to find the base and the height. So we're going to have a brand new formula for us to use. So I'm going to zoom in and write it right here. Okay, K, which we use for area. The only reason I can think of that we use a K is because we use A so often to represent the angles and the sides that we don't want to get confused there. equals 1/2 AB sine of angle C. And it doesn't need to be A, B, and C, but what it does need to be is any two sides, and this is what we call the included angle. So my niece Chloe's here with me, and she wants to say hi to you guys. You gonna say hi?
Yeah.
Say hi, math students.
Hi, math students.
Okay, before that cute interruption, here's what an included angle actually is. So just kind of to show you guys, if this was side A and this is side B, that means that side C has to be our third side, which makes this angle C. So this is what we call the included angle, and it's formed by these two sides. But we could just easily think of it as if we're using sides A and B, that we would use angle C. If we use sides B and C, we would use angle A and so forth. So on number 5, it tells us that we have side C, side A, and angle B. So we have all the information we need in order to find the area. So we're going to go ahead and write out the formula. So our formula is K equals, in this case, we're going to do 1/2 AC sine of angle B. So just remember that we need to use each letter. And we're going to substitute in the information that we know. So A is 91.6, C is 24.19, and angle B is 37 degrees. Now, the nice thing about this is we can just put this straight into our calculator. And when we do, we end up getting that the area is 666.8, and they didn't give us a measurement, so I'm just going to go ahead and write square units. And if you guys wanted to abbreviate that in any way, that's totally fine. Okay, so number 6. Once again, they're asking us to find the area. They're giving us angle A, which we know if we're using angle A, that means we need sides B and C, which are given to us, which is super nice. So we're going to go ahead and set this up once again. So K equals 1/2. This time, since I'm using angle A, I'm going to say BC times sine of A. And once we know this formula, we don't need to actually write that out every time, but I think that's a really good way to help you remember and memorize that formula. So I'm going to go ahead and say 1/2 times 10 times 19 times the sine of 71 degrees. And when I put that into my calculator, I get 89.8 square units. So the majority of the ones that you're going to deal with are that simple. We're going to go through one more that is a little bit more difficult. So moving on to number 7, and this is going to be our last example. We're actually going to cover word problems in a completely separate lecture. I know you're excited for that one. So looking at number 7, it says that we have angle A and angle B and side C. So obviously we have a problem here because I don't have the right information to substitute this into the formula. We know that we need to have two sides and the included angle. So we're going to have to use some of the knowledge we've learned in order to find those missing pieces. First of all, I know that angle C has to be 65 degrees, and I know that because of the triangle sum theorem. And I'm going to go ahead and find side A. Okay, and if you wanted to find side B instead, that's totally fine, but I'm going to write A over the sine of 37 degrees equals 250 over the sine of 65 degrees. So we're using the law of sines, and when we cross multiply and divide, I get 166.0. So at this point, I know sides A and C, so I have to use angle B in our formula. So I'm going to do 1/2 times 166 times 250 times the sine of 78 degrees. When I put this into my calculator, I get 20,296.6 square units. So once again, today's lesson, pretty straightforward. Hopefully you feel confident in your calculator skills and in solving a ratio like this. I know I went pretty quickly through that. But that's about it. Welcome back to second semester.